All right, hello everyone. My name is Alan Huang, and I'm part of Team Butterfly, and I'm here to bring you our game, Combat. Currently, this is a demonstration of the game that we based our game off of, which is the game Combat, also named that, from the Atari 2600, released back in 1977. And the reason behind why we chose this game was because we wanted to pay an homage to this, classic and kind of crucial in how it got us to video games today. This game from the distant past, and we figured the best way to pay this homage is to bring it to a much more modern screen and make it much more easier to access than having to buy an actual Atari 2600. And this also explains a lot of our design choices, such as the simpler GUI, which you will see later on, the very faithful graphics, and yeah. As for the structure of our code, we have Trinity here to take over that. Trinity, take it away.
For the first thing we decided to do was make individual components be classes. So we have a class for the tanks, for the bullets that the tanks fire out, and then for the obstacles. And basically these classes will keep track of things like the X and Y locations of where the tanks are, or the bullet. It will also keep track of things like angle, hitboxes, and then the size of all these items. And this is really critical for how the game, everything moves around, since we have methods for movement and rotation for the tank and the bullet class as well. And that basically will just either update the X and Y location depending on user input, which is in the controller part of our MVC, or it will automatically do it based on collision detection. For example, the bullet will just ricochet right off an obstacle and it should just move automatically. We also have a class obstacles, and that basically generates all the rectangles which make up these walls and obstacles, and then it has different layouts because in our game we have random layouts around, so that sort of changes things up, and that's basically what the obstacle track of. So we use an MVC model view controller code architecture. So we have another class called the game model that we use, and this one basically just initializes all of the different classes we talked about. So we'll have player 1, bullet 1, player 2, bullet 2, and then it keeps track of the tanks, the bullets, the obstacles, and the scoreboard. It also handles collision detection, bullet firing, and movement. And then it will also keep track of the other parts of the game, so the splash page and the game over. So, for example, if the scoreboard goes to 10 for like player 2, then it will trigger game over, and it will switch to the game over screen and say player 1. So aside from keeping track of the state of the game, we have also the game controller class, and this one basically just takes in user input for moving and firing. So for example, if player 1 presses W, then the tank should move forward. Again, all of these inputs are handled in a function called updates, which is in the game loop, which I'll talk about a little bit later. And then finally, we have the view part of our MVC, and that just basically displays everything using sprites and rectangles, and then just splitting everything to the screen. All of this is drawn together in a file called main.py, which is basically a file that contains the game loop or the super loop, whichever one you want to call it, and it will initialize the model, a controller, and a view class, and then just have a super loop that goes again and again, and that runs all those update functions to make a cohesive game.
All right. Well, here is a demonstration of the game Combat. First things first, it says right there, press space to start. Here we go. Now, for the controls, for player 1, which is on the left side of the screen, the controls will be WASD, and you have to press W and S, repeatedly to move the tank, one step at a time. There are several different directions that you can shoot from, and you can control that through A and D, and you shoot via E, and the bullets do ricochet. And as for player 2, which is on the right side of the screen, you control via IJKL, and the same layout applies with the WASD part. And instead of using E to fire, which is for player 1, player 2 uses O. And the way the game works is that You want to shoot your enemy before your enemy shoots you. Yeah, and well, here's a quick demo of somebody losing. There we go. The moment somebody loses, the game restarts and a random map is selected. This is, yeah. Now moving on, for the insights that we have learned throughout this game, we learned that developing software that's backwards compatible is very challenging. Optimizing the code to work on a range of devices reliably is difficult. This is because devices use different versions of compilers. Let me move. There we go. Using Jekyll can be very annoying because different distros of Linux, mainly due to permissions issues. Designing a site that actually conveys the theme of our game is also challenging because we want to make it look like it was made in the 70s, but that's not very appealing to the modern eye. We also exploring the various Pygame modules while working on a project like this was interesting. And as we went through our project, we deviated from the original plans in the architecture and code documentations, and this is kind of a result of overscoping and other complications. And as for our future plans, we wish to implement a AI-controlled tank, so it's not just this very lonely game of me playing against my left hand playing against my right hand. Add different game modes, like timed, endless, co-op versus AI, etc. Add a level selection screen, so it's not a random map every time. Make the game playable over LAN, and include power-ups, stuff that speeds up the tank, allows for continuous movement, shoots multiple projectiles, make it look professional. That's also one more thing that we want to try. And yeah, thank you very much for listening. We hope that you enjoy this game and have a great evening or great day.